welcome everybody. Very grateful and very excited, of course, to be part of this knowledge sharing event. And I witnessed some of the presentations already. They were very high level, so I hope to beat that expectation as well. A quick representation of myself. So Pedro Viña, I work for iCare Group. We are a European leader in predictive analytics and reliability solutions. We have about 450 employees. About 400 engineers, so a lot of engineers on site, have our own R&D, and you can have a look at our company profile in the magnificent booth, virtual booth that Fluidtech has on this event, or you can visit our website as well. Now, before starting the study case, I would like to take you through some basics to have a better understanding of the case. So we're going to look into the rotating equipment evolution as well as the lubricant evolution. Now, as we are all professionals in this domain attending this virtual summit, we know that the lubricant functions, of course, are to lubricate, to cool, to protect, to transmit power, or to seal, and that we have tons of load of equipment rotating at high speeds. And they are separated by a lubricant film with a thickness of a human hair or less, between 5 to 85 microns. Luckily for us, if you look at the journal bearing, we know there are some pressure distribution, so lifting our shaft up. So we know we are operating in what we call the hydrodynamic regime. Now, the evolution that we have seen from the OEM side and the trends we observe, what causes more risks in varnish, are of course the higher temperatures that they are trying to reach, higher pressure, discontinual or cyclic operations. We have our digital versus our mechanical controllers. We have higher flow rates. And on the other side, we see that the reservoirs have become smaller. The lubricant has a multifunctional function. We have finer inline filters, purified lubricant that we will see further on. We tend to have extended intervals, or that is the aim that we have. And we also see some of the manufacturers going for lower viscosity in terms of energy efficiencies. But we will see some presentations of that later, I've seen in the booth. Now, there are limits, of course. If you look at the higher temperatures, it's limited by the turbine blades. In this instance, I think it's about 1,200 degrees with some nitrate matrix available on the market. But there is also a thing to take into account, and that is our bearing material, of course. If you look at most of the journal bearings are from white metal or Babbitt metal. We have this tin or the lead based, and we see a limitation from 130, 150 degrees Celsius. They can go higher in temperature, of course, but there, the limit that's set over here is that we attack the matrix of the material as well. We soften the material. If you have, of course, a higher temperature that you have to reach, you have at the moment composite materials like PEEK, for example, for 270. We can go to ceramic bearings for 400 degrees. And so some OEMs also have what you call the electromagnetic bearings, so there is no lubrication and no varnish risk at all. Now, the oxidation instability, some causes are oxygen, of course, as we know, temperature, water, air, or particle contaminations. And we try to combat them, as you see, the turbine and compressor walls are very purified with some features of the lubricant. In additives like antioxidants to combat the oxygens. The temperature, we look at the viscosity index or even viscosity index improvers if you have some lubricants using it. But also the coolers are efficient in that way. The emulsifiers combating water, of course, anti-foam for our air. And for particles, we can go to corrosion inhibitors, metal deactivators and additives, but most of all, filtration is used to combat this issue. That's for the trends in rotating equipment. Very brief because I only have 20 minutes of time. Formulations, we see that we go from our API group, mineral always group 1, 2 to 3, depending on the refining process, of course. We have solvent refining, going to hydrotreating or hydrocracking, and having more purified lubricants, meaning that they are a lot more saturated, so we have less aromatics or unsaturated hydrocarbon chains, and the sulfur content has diminished a lot, nitrogen content, and so further on. Another trend, of course, in going from the group 1 to the group 2 and group 3 lubricants is the Hurricanes Katrina and Rita in 2005 in the east coast of the US and the Gulf Coast of Mexico, where they destroyed a lot of those mineral group 1 refineries. So you see the tendency is to go to the group 2 and the group 3 of mineral oils, also driven by the car industry looking for efficiency and environmental issues, of course. Now, if you look at the features of the 3 groups and we put it in a spider, we see, of course, that the group 2 and the group 3 mineral oils score better in oxidation stability. They are less volatile compared to the group 1. On the contrary, we see that there is a decrease in the aniline point. We also see a regression in the conductivity of the lubricant, going from 500 picosiemens per meter to 15 picosiemens per meter. So drastic reduction. And also the tolerance for contamination is far more or less than our group base 1 oils. And all those contribute, of course, to the higher varnish risk that we see at many of the end users today. Now, to be able to support all those risks, you see a lot of hydrocarbon molecules supporting the high loads that rotate at high speeds, but we need a certain Superman, a supermolecule. And supermolecule, as we can see underneath, is supporting that hydrodynamic film, is what we call our additives. Now, turbine and compressor oils, as we all know, are very pure in base oil, that we say 98 to 99.5% of purity. And then we have additives adding to it 0.5% to 2% depending on the lubricant type. From this, after 2%, 50% of those are antioxidants. And the others are, of course, anti-corrosion, anti-foam, demulsifiers, even anti-wear, depending on the multifunctionality of your lubricant. Now, looking at these super molecule antioxidants, it's a mixture or formulation of phenolic and amine type additives. And you see, depending on how the lubricant formulator combines those types of antioxidants, we get a better resistance to sludge, or as we can see, we can play with the RPVOT or the toast test as well. We know for the oxidation process, it's an autocatalytic process, and for mineral oil of the group 1s, we know it goes at a steady pace, depending on the time, and that we see, of course, for the lubricant 2 and 3, if you look at the comparison, that they will last longer in time, have a longer longevity, and it's because, of course, of the fortified antioxidant package. But what we observe in time is once they deplete, we get a rapid or an exponential oxidation process. Yes? And to give you a little summary of what you see beneath in the table on the right, the proportions of what we talk in percentages of antioxidants, looking at 1,000 liter bed, is a good soda bottle of antioxidants that has to support the features of antioxidant degradation, of oxidation degradation. Now, I started the balance, if you remember in the previous slides, with what is all the catalyst for a rapid oxidation process. And we had our oxygen, temperature, water, air, particle contamination, or a combination of all of those. Then you can see that we will shift our oxidation process to the left, making it more rapid. And that's, of course, what we do with our lubrication tests. I will go quick to some of those lubrication tests, but you will see that in the presentations that they are coming, that you will have more deep learning in understanding of the oxidation test. One, for example, comes from Koen Balman from Laborelic in the coming event, I think at 1 or 2 o'clock. So rapidly going through some stats, the RPVOT test, as we know, what we do is adding all of these, of some of those elements that are catalysts to the oxidation process, being in this instance some copper, some water, of course, the oxygen. We have a temperature of 150 degrees, and on top of that, we will steer it at 100 RPM in an angle of 30 in a vessel. So there is a lot of discussion going on whether it is a good or a relevant test regarding the remaining useful life of the lubricant. In my honest opinion, or modest opinion, it is more a test of the packages that the lubricant formulators play with antioxidants. If you will see in the triangle that the phenolic, for example, phenolic antioxidants have a limited temperature of 120 degrees, then you know if you have a fortified lubricant with a lot of phenolic, they won't last very long in the LRVS test compared to other packages that would. So it is more, I would say, a marketing term to play with, to have high LRVS values, rather than it says something about the good oxidation stability. Same for the toast test. There we have then copper and iron, some water, of course, oxygen, and 95 degrees. It's more favorable to the packages that the formulators can deal with. But as you see, it is a test that has a long duration, long hours before we see some results. So we aimed, and we see that a lot of those laboratories aim for a shorter test period. One of those other is the IP280 toast, of the dry toast, whatever it is called, depending on the supplier. Here we exclude the water. Of course, for gas turbine, you know, there's little water in the system because of the higher temperatures. So we have copper, iron salts, again oxygen, and then again the 120 degrees. So again, limiting the formulation of antioxidants. The one with the strong antioxidant packages, more to the aminic type, will have a longer resistance than one with preferably phenolic types. There's also another thing about the oxidation process, as we know, is the Arrhenius rule. Each 10 degrees of fermentation will halve the life of the lubricant. If we compare all those tests on this graph, you see that we are what they call the red zone, where we have a short lifetime of the lubricant, and we all know the cooler the lubricant is, the longer the lifetime of it. On top of it, new formulations, we see that a lot of amines, when they get depleted out and they bond with oxidation byproducts, they form these nasty varnish molecules that are very polar and like to stick to all metal types. Also, take into account the size, so filtration won't help. You will need other things when they are soluble to get them out of your system. Now, finally, I come to the study case. We have a case study from a gas turbine where the client had the end user had some problems from the beginning on in 2011. As a consultant, you always come in when the problems is so high that they are drowning. So I came in 2019, had an active period, as you can see, a short time, and then the non-active period was of budget restrictions, but also of the corona pandemic. And then you see again another two graphs where I came in again, and the only solution that I saw at that moment is to contact Fluidtech with their solutions for this problem. So as you know, for each problem is very complex in lubrication, so we like to chop it in some minor problems. We have chopped it in 3 cases, and you also see case 1 and 2 used a lubricant of type X, and case 3 is a lubricant of type Y. On this slide, I showed you the trends on LRVS value, viscosity, MPC value, ruler, and tensor. We have been fortunate for this end user that he does each month of every month an oil analysis. Not many do that, but it is, as you can see, it gives us very valuable information. The red dot you see, 446, is the condemning limit for the OEM of this gas turbine, being at 25% of the LRVS value. They're advised to change the lubricants. Now, luckily, the end user has attended one of our lubrication courses and knew that he could look at other values as well to have a longer longevity of this lubricant. So when I came in, it was not so far from the 25% you see the ruler and the aminic content. So there was not much more that we can do to save this lubricant. What happened then is they went into the flushing period or replacing of the lubricant. there was no flushing liquids available. The lubricant supplier couldn't supply any flushing lubricant. So they poured, they mechanically wiped out the reservoir, and then they poured in the new lubricant. And as you can see on top, normal RPVOT or ruler values, and when the oil analysis came in, we are about 50% of that value. So we know that at this time we had what we call infant mortality. So the sludge that was left into the system was already depleting the antioxidants of this lubricant. So when you look at the short amount of lifetime, it's 1,600 hours. At the time, the governance, reliability governance of the end users decided to go to another brand of a lubricant because they experienced good results on other sites. So they changed the lubricant formulation. The first results that came in, we saw a drop of the antioxidants, of course, and also you see an augmentation on the MPC value. So we knew that at the moment the flushing was not properly done, but as I said, due to budget restrictions, we had to let the company not be active until a later while when there was a lot of troubles again, and when we came in and we saw that it was an enormous increase of the acidity, but it was about 40% left of the aminic antioxidants, nothing more left from the phenolic. And we know as a fact that this is group 3 base oil, that the molecules are such, hydrocarbon molecules are such, are still fit for use. It's only the additive package that has been depleted very rapidly. And that's what we called Fluidtekin. Yo worked with him several times to get advice on how we can tackle this situation. So again, 7,920 hours for a gas turbine. Know that this gas turbine has a major overhaul each 4 years due to the turbine exchange of corrosion and erosion, of course. So we like to have an uninterrupted operation of 40,000 hours. That is the aim, of course. Now, looking for the root causes, what do? We do, of course, the Gemba walk as we go. We go on site to look what's happening. Problems cannot be solved from ivory towers or for posting it on LinkedIn. You have to go on site and see what's going on. Now, as you know, we like to share a lot of knowledge, so we talk to a lot of people, and depending on the people you talk to, if you look for a lubricant, you see the lubricant supply readily jumping to solutions, saying, okay, we have this special high performance turbine oil. If you look for lubricant B, we have varnish-free lubricant oils. The consultant say another additive package, and all the filtration supplies say we have some varnish removal systems. But the main thing is you go to the OEM and you see that nothing comes out of it. They say it is a normal operation, and we have many of those installed in the world. Okay, so we have to go to do our root cause analysis ourselves. As I said previously, we had to work with 2 different lubricants. One was group 2 base oil. The next was a group 3 based oil. And previously, in the past, it was a mineral group 1 oil. All experienced the same time, about a year, 1.5 years of, and they degraded completely. What you see over here, we analyzed, is that the slope of degradation is the same for the lubricants that we use, although they are very different in formulations. So it is not the lubricant issue. We also observe that at about 50% of the RPVOT value, you have an exponential 10 increase. And we can also see that in the oil analysis, it's due to the ester-based phenolics, that you see that they deplete out, and then we get this increase in acidity. In our cases, I don't say that it is for all cases it will be the same, but this is what we observed for our application this case study. Now, we know from the reservoir, and looking at the reservoir, that is a maze of compartments, and as we learned today from Ansuman Agrawal from Minimac, flushing is a very critical topic in having a longevity of your new and fresh turbine oil. Then we also look for the thermal degradation. What are the triggers? And as we know from our tribology, ESD of electrostatic discharge, microdieseling or hotspots are those triggers. Now, we see some hotspots. If you look at bearing 2 and bearing 3 in the return line, we have a temperature of 109 degrees. So it means that the bearing temperature is much higher, being 15 or 20 degrees higher or even more. So plotting that again on the Arrhenius rule and loop test, we see that we are again in a red zone. And you might say, okay, the lubricant is certainly the group 2 and the group 3 are oxidation stable for higher temperature. They'll be testing also at 150 and 200 degrees. That is true, but we have to look, of course, in this case, at the additive package. And then we see, of course, okay, what is causing on the RPVOT value of 50% that we say an increase in acidity. It was the ester-based phenolics, and the ester-based phenolics, we will see at this temperature they will deplete out. And that is also what we see in our tests. And of course, another things of concerns is because of these higher temperatures, okay, what is going on with our journal bearings? They're also a risk. Luckily, the temperature that we see on these trends, it's plotted each hour we get this information in, is very steady. So no troubles in that. But if you look at the exchange of the turbine, I hope that the journal bearings will be exchanged as well. So looking into this problematic area that we call hotspots, there are ways going to defect elimination, that you go to the redesign of your gas turbine, and we can come up with some ideas how to create a thermal barrier to protect our journal bearings that they don't see that high temperature. But again, as I said, if you contact the OEM, they want to see, don't want to hear, and don't want to speak about it. And that's a pity, because the total cost of ownership that we have on this gas turbine is an added 50 to 100,000 euros per lubricant exchange. And if you know that we reach about 8,000 hours and we want to have an uninterrupted operation time of 40,000 hours, it means 5 times that value. And it doesn't take even into account the production loss of the company. So if you were an engineer and you have to look for a new turbine, which turbine would you buy? Would you buy the same brand or the same type? I don't think so. So the path forward in our solutions to tackle this problem is find, of course, the possible root causes. But there, of course, as I say, we need the interaction with the OEM because we can find the root cause or spot something. But if design technically nothing is going to be done, the root cause will remain the same. There is also the flushing procedure, of course, where we have to look into, taking also in account that the gas turbine supplier has a well-written flushing procedure. So this will be implemented. Then the all-in analysis data that we get on a monthly basis, we will convert them to actionable items on which data is which trigger to do an action. And now to mitigate the rapid lubricant degradation that we use today, that's what I call the YOIN, is to use the Fluid Tech Boost VR Plus. It's a solubility enhancer, so it will contain the varnish precursors more in solution than they deplete out. And it's also a varnish remover for what I said, the flushing period, flushing wasn't done properly, so it will remove some varnish of the system as well. And then, thanks to the solubility enhancer, keep them in solution. And then at the ESP unit, so we do some chemical filtration to remove what we call the varnish precursors or the organic soft materials. And then the next step, because you see, okay, we have tried 3 different formulations, group 1, group 2, group 3. Isn't there a fill for life lubricant? And that is what Infinity tells us from Fluidtech. We are going to look at as well, whether it is a good solution to tackle this problem. But a final word, please, for collaboration, especially with the OEMs. We saw in the presentation given by Andreas Koop at Siemens Energy that there is a possible exchange in information. They also we learned from Andreas also that they redesigned the cooler who had fouling issues. So we know that the OEM has a lot of installations worldwide and has had to get a lot of feedback. Yes. And that's what we expect to collaborate more, because Industry 4.0, as we know, it connects equipment data, but it also connects people, and people who like to share their troubleshooting and knowledge experiences, like in this virtual summit. So 5 minutes over time, but there is enough room for questions and answers, I think, if you pops up again. Thank you for the attention.